Hi students, I am continuing the chapter Trigonometric functions, and today I am going to discuss some problems and introduce some trigonometric identities. So listen carefully, it's an important topic. This is our first question. Find a sine of 765 degree. So let's start the solution of this question. So given that we need to find the value of 7 sine 765 degree. So we know that sine of 2 pi n plus theta is equal to sine theta, right? Or this is in radian, right? So if we convert it into degree, this becomes sine 360 n plus theta is equal to sine theta. So if we convert the given question in the form of 360 n plus theta, so we know that 360 into 2 is 360 into 2 is 720, right? So our given value is 765. So 765 minus 720 is if we subtract these two values, we get 45 degree. So if next I am going to convert this sine of 765 degree into this form, that is sine of 720 plus 45 degree is equivalent to sine 765 degree. Okay, and this 720 can be replaced into 360 into 2 plus 45 degree. So comparing these two terms, here n is 2 and theta is 45 degree, right? So next we know that sine 360 n plus theta equal to sine theta. So sine 360 into 2 plus 45 degree become sine 45 degree. And it is equivalent to sine 45 degree. In this question, here we are using this formula. Okay, sine 45, and we know that the value of sine 45 is 1 by root 2. Okay, so sine 765 degree is equivalent to 1 by root 2 value. Okay, I hope you understood. In this question, we need only these two results. Okay, this is our next question. Find tan of 19 pi by 3. Okay, so let's start the solution of this question. Given that we need to find out the value of tan pi by 3. Okay, so we know that tan n pi plus theta is equal to tan n pi plus theta equal to tan theta. So next I am going to convert the given question into this form, tan 19 pi by 3 into tan n pi plus theta form. Okay, so this can be also written as this, the numerator can also be written as 18 pi plus pi. 19 pi is equal to 18 pi plus pi, right, divided by 3. And divide individually, and we get tan 18 pi by 3 plus pi by 3. Okay, and this will further equal to tan of 18 pi by 3 means this 3 will cut and we get 6 pi here, and the remaining term will remain same, tan 6 pi plus pi by 3. So comparing these two terms, here n is equal to 6 and theta is equal to pi by 3. So this can be also written as, or this is also equivalent to tan theta. Here theta is pi by 3, right? So tan pi by 3, and we know that the value of tan pi by 3 is root 3. Okay, so the value of tan 19 pi by 3 is equivalent to root 3. I hope you understood. In this question we need only this result, that is tan n pi plus theta is equal to tan theta. So convert the given question into this form. This will lead to our answer. Okay. In this question we need to find the value of cos of minus 1710 degree. Okay, so let's start the solution of this question. Given that cos of minus 1710 degree. So we know that cos of 2 pi n plus theta is equivalent to cos theta. So the given question is in degree form. So convert this form into, this is radian, right? So this form into degree, that is 2 pi is 360, right? So 360 n plus theta, cos 360 n plus theta is equal to cos theta. Okay, so note that this minus here. So next I am going to convert this into this form. So we know that cos theta is equivalent to cos of 360 n plus theta, right? So here theta is this. So converting this theta into cos of minus 1710 degree is equal to cos of 360 n plus, here theta is minus, so this plus is changes to minus here, minus 1710. Okay, next we need to find out the value, that this n, which is nearly equal to the given degree value. So we know that 360 into 5 is equal to 1800. Okay, so next I am going to replace this n by 5. The answer is does not altered. So cos of 360 and 5 minus 1710 is equivalent to the given question. Okay, and which is equal to cos of 360 into 5 is 1800, and the remaining portion is right here, and 1800 minus 1710 degree will leads to cos 90 degree, and this is equivalent to this value, that is cos of minus 1710 degrees equivalent to cos 90, and we know that the value of cos 90 is 0. Okay, so here note that using this result, that is cos theta is equal to cos of 360 n plus theta. Here theta is given, so just replacing this theta, we get this step here, and next we are going to calculate the value of n, which is merely equal to this value. So we know that, and 360 into 5 is 1800, which is near to our given value, given degree, and substituting here and minusing these 2 degree, and we get it is changes to a positive value. This negative value is very equivalent to this positive value, and this cos of minus 1710 degrees equivalent to cos 90, and we know that cos 90 is equal to 0. Okay, I hope you understood. And this is our next question. Find cosec minus of 1410 degree. Okay. So let's start the solution of this question. Here also a negative is present in our question. So given that cosec of minus 1410 degree, we need to find out the value of cosec of minus 1410 degree. So we know the reciprocal of cosec is sine. So we know that sine of 2 pi n plus theta is equivalent to sine theta, or it is converted into degree form, that is sine of 360 n plus theta is equal to sine theta. So we know that the reciprocal of sine is cosec. So this condition is also satisfying in cosec theta. So cosec 360 n plus theta is also equivalent to cosec theta. So here next I am going to write here cosec theta is equivalent to cosec 360 n plus theta. So next I am going to replace this theta by our given degree, that is cosec of minus 1410 degree is equal to cosec 360 into n plus, here minus is here, so I write minus here, so minus 1410 degree. Next we need to find out the value of n, so which is near to 1410 degree. So we know that 360 into 4 is equal to 1440. So replacing this n by 4, that is, this is equivalent to cosec 360 into 4 minus 1410 degree, and the value of 360 into 4 is 1440, which is which is subtracted from 1410, and we get cosec 30 degree. So cosec minus 1410 degrees equivalent to cosec 30 degree. So we convert this negative form into positive term by using these steps. Okay, so we know that the value of sine 30 is 1 by 2. So reciprocal of sine 30 is cosec 30. That is, the value of cosec 30 is 2. Okay, I hope you understood. So sine 30 is equal to 1 by 2. Cosec 30 equal to 1 divided by sine 30, and which is further equal to 1 by 2 is equal to 2. Okay, I hope you understood this question. This is our next question. Find the value of sine of minus 11 pi by 3. So let's start the solution of this question. Given that sine of minus 11 pi by 3. right? So we need to find out the value of sine of minus 11 pi by 3, and we know that my sine of minus theta is equal to minus sine theta. So here theta is theta is 11 pi by 3. So replacing applying this condition, this sine of minus 11 pi by 3 can also be written as minus sine 11 pi by 3. Okay, by using this condition. Next, I am going to convert this 11 pi by 3 into the denominator have 11 pi here. So we know that 12 pi minus pi gives 11 pi, right? So replacing this 11 pi as 12 pi minus pi, and also the denominator is remained same, and dividing individually, and we get minus sine of 12 pi by 3 minus pi by 3, and which is further equal to 12 by 3, and it cut into 4. So we get minus sine of 4 pi minus pi by 3. Okay, next I am going to draw the fourth quadrant. We know that this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. And here it starts from 0, pi by 2, pi, 3 pi by 2, and 2 pi, and so on. Okay, and it continues its rotation in the similar way. We get here 4 pi, right? So the angle is given that 4 pi minus pi by 3, that is 4 pi minus, if we subtract 4 pi minus pi by 3, the angle lies in fourth quadrant, right? 4 pi minus pi by 3 means the angle lies in fourth quadrant. In fourth quadrant, only cos and the reciprocal of cos is sec are positive. Here, given that we need to find the value of sine of 4 pi minus pi by 3, so the value of sine is negative in fourth quadrant. So I am writing this minus here, and value of sine of 4 pi minus pi by 3 or sine of 4 pi minus theta is equal to minus sine theta. So replacing this theta by pi by 3, we get minus sine pi by 3 here, and this minus of minus will become positive, and the answer will become sine pi by 3, and the answer sine pi by 3 is equivalent to 180 by 3, that is 60, right? Sine 60 root 3 by 2 is the answer of sine of minus 11 pi by 3. Okay, so sine of minus 11 pi by 3 is equal to root 3 by 2. This is our next question. Find cot of minus 15 pi by 4. So let's start the solution of this question. Cot of minus 15 pi by 4. And we know that tan of minus theta is equal to minus tan theta. So we know that the reciprocal of tan is cot. So cot of minus theta is also equal to minus cot theta. So by using this result, this can be written as minus cot of 15 pi by 4. Okay, so next I am going to convert this 15 pi into 16 pi minus pi. We know that 16 pi minus pi is equal to 15 pi, right? And the denominator is remains same, that is divided by 4, and it divides individually, and we get minus quote of 16 pi by 4 minus pi by 4, which will further equal to minus quote of 4 pi, and this will cancel, and here we get 4 pi minus pi by 4. So next I am going to draw the 4 quadrant, and we know that first, second and third and fourth quadrant are shown here, and 4 pi lies in here. Here is 2 pi, 0, 2 pi and 4 pi is here. So 4 pi minus pi by 4, that means the angle lies in fourth quadrant, and we know that only cos and sec values are positive in fourth quadrant. But here we need to find the cot of 4 pi minus pi by 4, or cot 4 pi minus theta is equal to minus cot theta. Here theta is replacing by pi by 4. Cot of 4 pi minus pi by 4 become minus cot of pi by 4. This minus and minus will become positive, and we get cot pi by 4. Cot pi by 4 is equal to tan pi by 4 is equal to 1, and cot pi by 4 is also equal to 1. Okay. Next I am going to introduce some trigonometric identities. So it's very important. Everyone must by heart these trigonometric identities. Okay. The first identity is sine of x plus y is equal to sin x cos y plus cos x sin y. Next one is sine of x minus y is equal to sin x cos y minus cos x sin y. Next one is cos of x plus y equal to cos x cos y minus sin x sin y. So note that here minus is here. Okay. So here plus, the result we have minus here. So cos of x minus y is equal to cos x cos y plus sin x sin y. Okay. So these are very important trigonometric identities. So everybody should by heart these trigonometric identities. Okay. Next identity is tan of x plus y equal to tan x plus tan y divided by 1 minus tan x tan y. So here we need proof of this identity. So let's start the proof of this identity. And we know that tan of x plus y can also be written as, or tan theta can also be written as sin theta divided by cos theta. So tan of x plus y can also be written as sin of x plus y whole divided by cos of x plus y. Okay. Next I am going to expand sin of x plus y using trigonometric identity. Sin of x plus y equal to sin x cos y plus cos x sin y whole divided by, using trigonometric identity, cos of x plus y. The expansion of cos of x plus y is cos x cos y minus sin x sin y. Okay. Next I am going to dividing numerator and denominator by cos x cos y. So dividing numerator and denominator by cos x cos y, we have sin x cos x y sin x cos y by cos x cos y plus cos x sin y by cos x cos y whole divided by cos x cos y by cos x cos y minus sin x sin y by cos x cos y, and which will further equal to, if you observe the numerator, here cos y is cancel each other, and again cos x is cancel each other. Here the whole in the denominator, this whole term is cancel each other, and here okay, and we get sin x by cos x plus sin y by cos y whole divided by 1 minus sin x by cos x into sin y by cos y. Okay, if sin theta by cos theta is tan theta, then sin x by cos x we can replace it by tan x plus sin y by cos y by tan y whole divided by 1 minus sin x by cos x is tan x, and sin y by cos y is tan y. So we get our final result, tan of x plus y equal to tan x plus tan y by 1 minus tan x tan y. Hence proved. Okay, I hope you understood. So by heart this formula too. Next identity is tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. So let's start the proof of this identity. Here tan of x minus y can also be written as sin of x minus y divided by cos of x minus y. Okay, here expanding using identity sin of x minus y, it is equal to sin x cos y minus cos x sin y whole divided by cos x minus y is equal to cos x cos y plus sin x sin y, and dividing numerator and denominator by cos x cos y, we get sin x cos y divided by cos x cos y minus cos x sin y divided by cos x cos y whole divided by cos x cos y divided by cos x cos y plus sin x sin y divided by cos x cos y. So if you observe in numerator, here cos y cancel each other, and here cos x is cancel each other, and here in the denominator these two cos x are cancel each other, and the remaining terms are sin x by cos x minus sin y by cos y whole divided by the whole term will cancel each other here, right? Cos y and cos y, that is the remaining terms are term is 1 plus sin x by cos x into sin y by cos y. Okay, and this can be replaced by sin x by cos x is tan x minus sin y by cos y is tan y whole divided by 1 plus sin x by cos x is replaced by tan x, sin y by cos y is replaced by tan y. So hence we get our identity tan x minus y equal to tan x minus tan y by 1 plus tan x tan y. So hence proved. So this identity is also important, so by heart it.